this is all about your questions and your asks. So interrupt at any time. This is the 10th time I've had a chance to visit with you all, and always try to do something different. But this time we've heard a lot of themes from people about cover crops, and Bill Robertson just touched on one aspect of cover crop that we're going to get into a little bit more detail, because it's one you need to be thinking about, and that's the soil microbiology of these cover crops. Because right now the major companies, the major crop protection companies, they are partnering with companies like Novartis and other makers of enzymes and sprayables. So they're extremely interested in finding those bugs and bug products. Koch Agronomics is doing it as well. They're looking for finding something they can sell you. They want to find a biological that they can sell you. And what I think Alan and I and other speakers are going to show you, that a lot of those things you already have in your own field. You just need to herd them and encourage them and nurse them and get the right ones to grow. And you're really fortunate that the things that you do naturally to make better soil also help better bugs. They're just a couple minor tricks, and we'll touch on those just briefly. So I'm going to talk about enhancing soil health with common cultural practices instead of going out and buying something that you put in a jug that you buy and you spray on. And I do want to recognize, I've got a couple partners in crime from Texas Tech. A lot of this work is being done in Florence, South Carolina, and Texas Tech. Both extremely tough soils for microbes, but the USDA is starting a new location in the Upper Delta, so hopefully we're going to get this kind of information coming out of the Delta here real soon. So with that, let me jump into it. The things that contribute to soil health, we're all on the same page as these. We need saprophytes to break up microflora. How deep would the organic matter be in a field if we didn't have saprophytes, right? It'd be up to here, right? You know, we've got to have something that cycles it. So beneficial fungi and bacteria that Bill's been talking about. Organic matter, we all know. Moderate level of nutrients, low physical stress and chemical disturbance. Those are the no-brainer things. What we're going to talk about is the one that's not a no-brainer, which is moderate soil temperatures, particularly on a diurnal basis. That's the key take-home message I want to leave you with. So the roles that microbes play, we're seeing all sorts of great benefits besides giving you soil structure. Farmers and agronomists like myself tends to think about the physical things, how well that soil holds up and how well it moves water. But we've got a lot of other things besides the cycling of carbon and nutrients. Root uptake, root function, that's obviously really, really critical. Soil structure we talked about. And also there's some new evidence beginning to show that some of the mycorrhizal, the ectomycorrhizal, really important in protecting you from pathogens. Just like with your gut microbes, the beneficial ones help protect you from the harmful ones like Clostridium difficile. When we think about microbes, the very simplest level that we look at is how many? What's the total volume? And that's important to be thinking about. That is the community size. But it's really the next level that we drill down into that are important to push it to the next level, not only of the science, but hopefully eventually to the management. So we need to know what the composition is, or what's the composition of protozoa, bacteria, fungi, the different types of fungi. And we're really fortunate that medical science is so far advanced in this, looking at our guts, and they're coming up with cheap, low-cost ways, DNA ways, to screen very rapidly what the distribution of composition is in that soil. But the next level that we really need to get to is not only what is the composition or that community structure of the guts in either your microbe or in the soil, but what functions do they bring? Because that's really where the rubber meets the road from you all's standpoint, is what those microbes are doing. And we're not going to get to that level other than just some indirect evidence on that. So the composition of the microbes is really important. At a very simplistic level, we can think about fungi and bacteria as a very elemental way to start thinking about these. And fungi in general are much more efficient than bacteria at assimilating and protecting nutrients to keep them available in the soil for roots and avoid their loss. And fungi also appear to be more protective from pathogens. And if we look at the management of the fungal to bacterial ratio, so generally fungi good, bacteria bad is a very simplistic way to think about it. If plant residue is added, tillage reduced, the fungal community gets to be a little larger in relationship to the bacterial. And so likewise, if you have tillage, bacteria tend to dominate. And fungi, this is where we're getting into a little bit more. Fungi are more impacted by temperatures. The temperatures, particularly the swing of temperatures, is really bad for higher life forms, whether it's humans or whether it's roots or fungi, and you get to an extreme environment, and the few things that can survive are bacteria. So how do we improve the beneficial organisms in the soil? And obviously, the things that we do take for granted are plant residues, and we've heard a lot of talks on no-till and cover crops here, and decreasing the soil disturbance. You know, the best way I like to think about that soil disturbance, it's like if you have one meal a year, maybe two meals, one at Thanksgiving and one at Easter, right? And you have 2,000, actually maybe 20,000 calories each day. That's not going to be very healthy. And that's really what we do with our soils when we do a complete tillage twice a year. Those microbes get to eat really, really well on Thanksgiving and Easter, and not a whole lot in between. But if you leave that residue on the top, particularly if you contribute it to with a cover crop, those microbes get to eat year round. But the one that we're not often thinking about is the daily temperature range. And so I'd just like to show you some of the work that's being done in West Texas. And it's being done there because you've got some of the lowest organic matter. If you get 1%, it's a miracle in West Texas. There's growers who will hit 2% with very long-term no-till and cover crops. But the harsh conditions, the low rainfall, the high temperatures baking down on that are really tough on the soil. So what these scientists have done now for 4 years is look at what's called the daily temperature range. And it's just like humans. If you go out and it's really cold and you don't have a jacket on, and then you come back in where it's 72 degrees, and then you go back out where it's really cold, and the body temperature swings, that's not good for any higher life forms. It's not good for roots, and it's not good for fungi at all. So the method that they're using is they're looking at the daily temperature range over a 24-hour period, which is the max temperature minus the minimum temperature. So this is what it looks like on a small research plot. When you put a shade blanket, so you put one of these things out, and they've also done it with putting out straw. If you put out a shade blanket, here's the zero surface, and unfortunately these are centigrade, but you can just about double these. So this is the daily range. So we're seeing a daily range of about 30 degrees centigrade, which is a daily range, that's about a 70-degree swing in temperatures. And basically, as Bill Robertson says, if you walk out there and that soil is so hot you don't want to be barefoot, you know it's not good for the microbes, it's not good for the roots. But what's impressive is how that transfers down even into a 6-inch depth on a daily basis. Now we know as temperature, as it moves down in the soil, that wave smooths out, but you still have a big swing in temperatures. The shade cloth is the blue and the bare is the red. We still have a wide swing even at the 6-inch depth. And this has dramatic impacts on the microbial biomass. This is sampling the surface 6 inches of soil, 15 centimeters of soil, and particularly in the hot part of the year, the July, August, and September, you can see the control, which is no cover at all. We don't have nearly as many of total microbial biomass in that surface 6 inches. And the other two lines, the red and the green there, are either the shade or the stubble. A little bit of variability on this bouncing around, but pretty consistent with those 3 hot months. And if we start looking at what the functionality of these nutrients are doing, this is where we really want to go. What is that more stable temperature doing for us? And obviously in West Texas, they're most interested in water, but they're also interested in nutrients as well. And here's just an example of what's happening with nitrate. So again, the control is this first bar, and you can see the nitrate goes through the roof in August and September under these really hot conditions, where it's in a highly released version. The high temperatures mineralize it, put that nitrogen into solution where it's vulnerable to leaching, it's vulnerable to loss, but also where you have reduced uptake from that hot temperature on the root. These scientists are just beginning to use these medical techniques of looking at the gut microbes on the DNA and starting to look at how these populations of microbes are changing. And so here is a bear, and you can see it's largely the gram-positive bacteria which predominate. This is a statistical method that allows you to separate out these two wide populations or communities of microbes. And where you have the stubble, we have more gram-negative, but also the arbuscular mycorrhizal fungi, more diversity, some protozoa showing up in here too, more diversity of microbes under that stable temperature. The work has been going for a couple years now in grower fields. One of the years I actually took the residue and just pulled it off to the side, picked it up, and removed it, so everything else about the soil was the same. And this is actually this is one of those plots where the residue is actually picked up and pulled. This was corn residue, cotton was planted into it, and again, the daily swing. So this is the magnitude of swing on a daily basis. We're looking at a 20-degree centigrade swing, which is probably a 50-degree diurnal swing from high to low with the bear, versus the stubble, about a 3 to 4 degree swing. So very, very tight with that stubble. This is on the surface. And again, this is the 15 centimeter or the 6 inch deep. We're seeing the same reduction in amplitude, but that heat pulse, which is being created on the surface, is pushing all the way down. So we're seeing that diurnal fluctuation even at 6 inches. So the top 6 inches that Bill talked about as being critical to have root function for water and nutrient uptake is impacted by that diurnal swings of temperature. So I'm going to wrap up. I'm the warm-up speaker for today, so that's why I just wanted to introduce a different twist on the soil microbes that we need to be thinking about, and one of the other benefits of no-till and cover crops. Obviously, the ones that growers are mainly focused on, I would think the bulk of you are looking at suppression, seeding weeds, blowing sand, soil erosion, rainwater infiltration, surface evaporation, and root soil water uptake. Obviously, this is the driver for West Texas. We're seeing where we have that better control of daily temperature. The roots are a lot more functional, and we're getting better use of that rainfall. That part of the world, the average amount of rainfall they get during the summer is a ½ inch. And if you have those kind of hellacious temperatures in the surface, that ½ inch just drops in and then evaporates because you don't have functioning roots to extract it. So with that, I'd like to introduce the main event for today, because all of this up here doesn't happen unless you can get a healthy stand. And the challenges of getting a stand, particularly at the northern edge of the cotton belt where it's cold and with a crop like cotton, are very, very substantial. We're fortunate we've got Alan to help you on that. And why don't we hold questions until Alan's through, and then we can both address questions. Thank you. Thanks, Alan.
Thanks, Coder.